In the previous lab, we used a standard access control list to filter based on a specific source IP address. In our case, it was 10.16.0.10. But what if we wanted to filter or block the entire subnet or a whole range of addresses? We certainly don't want to have to put 254 different entries to block all the hosts in a subnet. Well, we can leverage a technique that we also took a look at in OSPF skills, and that is the concept of using a wildcard mask in conjunction with access control lists. Let's take a closer look. So let's use the same topology again. Here's our Arizona location. Here's VLAN 10, and its IP addressing space is 10.16.0.0 with a 24-bit mask. Great. Now, if we wanted to use a standard access control list, and we wanted to permit or deny matching on just that network and not really care about the hosts, what we could do is we could add an access control list that includes the use of wildcard masks. Now, wildcard masks are the same concept that we talked about when we looked at them with OSPF. And a great way to think about a wildcard mask is think about the normal mask with an M and the inverse or the inverted of that, which is a W. That's a great way to remember mask versus wildcard mask. So if we have a 24-bit network, the mask for that network would be 255, 255, 255, 0. All right, and the wildcard mask would be the inverse of that. So anywhere there's a 1 in the mask, you'd have a 0 in the corresponding wildcard mask. So 255 in binary would be all 1s, and if we flip all those bits, the inverse of that would be a 0. So you take all the 255s, they become 0s, and then for the last octet of the mask, which is 0s, you invert that, and it would become 255. And this is our wildcard mask for a 24-bit network. And here's what it means. When we create the access control list, we'd use the syntax of access list. Give it a number. Let's go ahead and use 2 for a new standard access list, space. And let's imagine we want to deny anybody coming from the 10.16.0 network. We'd use the keyword of deny, space. We'd put in that network, 10.16.0.0. And with this access list, we want to tell the router to match and that we care about matching on these first 3 octets. And to do that with a wildcard mask, we use 0.0.0, which means match exactly on the first octet, second octet, and third octet. I care about matching those. That's what these corresponding bits from the wildcard mask says. But I don't care, says the last octet of the wildcard mask. I don't care about bit 1, 2, 3, 4, 5, 6, 7, or 8 from that last octet. So they can be whatever they want. I'm not going to care regarding matching purposes, because all we care about is matching the source address that matches on the first 3 octets of 10.16.0. That would include .10, .20, .30, or any other host addresses on that network address space. So there's our syntax. So basically we're denying on the 10.16.0.0/24 network using this wildcard mask. And the action is going to be deny. Now, what's the problem if we just created this one access control list and we applied it inbound on gig 00 on router 1? And I would like us to think about that for a moment. What is the problem, if any, with a one-line access control list that says deny and then applying it inbound on that interface? And if you're saying, well, Keith, you said there's an implicit deny where everything's now going to be denied on that interface, you'd be right. So in an access control list that's being used for packet filtering, we'd want to include at least one permit statement somewhere if we want traffic to be able to go into that interface. So let's add our second entry in access list 2 for permitting everything else. So our second entry would be any, meaning any source IP address and permit. And the syntax for that would be access list 2 permit space any. And then to apply this access control list to this interface in an inbound direction, we'd use the command in interface configuration mode IP space access group 2 space and then the direction. And we're going to apply that inbound. And that way the security guard is comparing all traffic against this list as it comes into this interface on the router. So in this video, we've taken a look at the benefit of a wildcard mask. So instead of having to do 254 entries for all the IP addresses and all the devices on a certain subnet, we can plug in the permit or deny statement with a match on the network and then have the wildcard mask simply say, yeah, we only care about matching on the network portion. Don't worry about matching on the host portion. And that way we can get the entire subnet. Also, if you haven't already, I would encourage you to take a look at the skills regarding describing and implementing OSPF, because the concept for wildcard masks are implemented there as well. And between that and this, they'll help you reinforce the skills of using a wildcard mask. So now that we've taken a look at some of the syntax and methods for using a wildcard mask in the very next video, we'll take a look at applying it in the lab. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.